Hello everyone and welcome back to the Kohi game engine series. Today we're going to talk about writable textures. So before we jump into the video, I would like to take a quick minute and thank the partners of the channel. The partners are the highest tier of support both on YouTube and Patreon, and they are Caden, Eearslya, Gerboles Inc., Super Awesome, and Wensheng. I'd also like to thank all the other fine folks that appear on the screen here. Your support is greatly appreciated. Thank you very much. If you'd like to support the channel and support my work, feel free to have a look at the YouTube membership, or if you prefer Patreon, you can check out patreon.com/TravisVroman. So, writable textures, otherwise known as render targets, or just a texture that's not necessarily read-only like the textures that we've been dealing with so far. So an example of a writable texture might be the textures or images that we're using for the swap chain that actually get rendered to. So that's the most common use case, is we can render something to a texture and then be able to use it for something else. And so part of our upcoming changes to support various types of render targets is having a writable texture. And the only difference really is the type of memory that's used for that, as well as some additional functionality that's going to be added to those writable textures. So we're going to implement that today, and most of that work is going to be sort of a wrapper around what we already have or what already exists. And speaking of wrapper, we are also going to be at some point wrapping our swap chain images as well. So at least for right now, what we're going to do is we're going to update our textures in our texture system, as well as a couple places in our renderer to add some additional functionality that we're going to need for writable textures. But before we jump into any of that, there are a couple of changes that I would like to make. So one of those things is the naming of a couple of things within our renderer system here. So most of the things that we have are named sort of noun and then action, right? So we have shader set uniform, or we have shader release instance resources. But then we actually have an inconsistency in our naming, where we have we have create geometry. So we're going to have to come back to that at some point too. But we also have this create texture and destroy texture. And we really want to sort of flip that around because it just doesn't really match the naming scheme that we have. So I want to really quickly just sort of rename a couple of these things. So create texture is now going to be texture create. And then destroy texture is now going to, of course, be texture destroy. And it seems like a relatively minor thing, but as we catch stuff like this, inconsistencies in the code base, I'd like to go ahead and fix them so that we make everything as consistent across the board as possible. So this means that we're going to also have to update this on the renderer front end and back end. As you can see here, the C files have already been updated because the front end just sort of passes that stuff through. So we have our texture create and our texture destroy being called here. So that means that we have our renderer create texture that needs to be renamed. So I'm just going to rename that to renderer texture create. And then we also have our renderer destroy texture, which I'm going to rename to, as you guessed, renderer texture destroy. Okay, and of course that also affects the H files as well. So we have that. And then we also need our Vulkan backend, because that also has the texture functions as well. So we have our Vulkan renderer create texture and our Vulkan renderer destroy texture. So we're just going to quickly rename these things as well to Vulkan renderer texture create and Vulkan renderer texture destroy. And we'll go ahead and apply that. Okay, and I'm just going to go ahead and save all just to be sure that all those changes are saved. So before I actually move on, I'm just going to do a clean and a rebuild. And it looks like we missed some stuff. Let's see. So render backend C. Right. So these did not automatically update. I figured there was going to be at least one of these things here. Vulkan render, texture create, and texture destroy. Those actually look correctly. Did they not update in the H file? They did not for some reason. So I'm just going to go ahead and update these as well. The refactor works pretty well most of the time, but it's not perfect. Sometimes it does miss stuff like this. So that is one of the reasons that I'm going ahead and adjusting all this stuff now. Let's see, undefined reference to Vulkan render texture destroy. Didn't I clean that? Let me try cleaning and rebuilding. Entry.c. Why is that when it's linking? Interesting. So doesn't our clean get rid of the test bed? I thought that it did. Let me double check. So our test bed should be fine. We're not getting any errors there. And our bin, all we have is our tools, which isn't getting cleared. That actually is an issue. So we actually probably should fix that real quick. Oh wait, no, never mind. Ignore that. That's actually something that's coming in the future. Let's see. So why is this not, what did I miss here? What undefined reference to render texture destroy? Let's do a quick search here. Is it saying it can't find that? No, it's found that. And it looks like it's mapped it correctly. That's really strange. Why is that failing? That is something I've not actually run into before during a refactor, so that is actually pretty interesting. So let's troubleshoot this and see if we can figure out what exactly is going on here. If we delete that, you know what, let's actually just delete the OBJ folder. And let's also delete the bin folder. Let's just get rid of both of those things. Delete. Okay. Let's build again. Yeah, it's still failing. I wonder what, there's got to be something left over that we didn't change somewhere. So I guess let's go to the build. And I guess it's actually failing at the test bed. So let's actually go ahead and toss the V in here for the linker flags real quick, just to see what is going on. That is really strange. I'm not 100% sure what is going on there. So let's have a look at everything that's changed, because maybe there's something that's changed in one of these files. I'm actually going to revert this. Maybe there's something that's changed in one of these files that should not have been, or something that was not changed that should have been. So that looks fine. That looks fine. That's just a rename on both of those. Yep, okay. So this looks fine. This also looks fine. I mean, all we're really doing is renaming here, so I'm not really sure why this is having such an issue. Render a texture create. These look fine as well. And the texture system itself, let's render texture destroy. Oh, wait a minute. Did we? Yeah, this is probably the issue right here. Why is this? This is actually missing an R. That is the problem, I think. It's talking about render texture destroy, but this was actually renamed incorrectly. So let me actually. This is missing an R. Let's see if that was anywhere else. I didn't notice that right away. Okay, the render front end, render texture, create destroy. Okay. Okay, let's clean again and rebuild. It's still saying Vulkan render texture destroy. Vulkan renderer texture destroy. This is the same string, right? Let me just copy this. That's it right there. What is the C file? Oh. Oh. Okay. I can't find it because this actually didn't rename. So again, like I said, this refactoring is not perfect. It didn't actually, for some reason, rename this. So it should be Vulkan renderer texture destroy. If I build it now, it'll work. Okay. So slight detour there, but that is how you find that type of an issue if you run into that. Generally speaking, it means that something was sort of declared but not defined somewhere, and when you go to link it, it fails. Okay, so let's go ahead and just run just to be absolutely sure that we're good. We should be. Okay, so our rename is good. So that was a lot more time than I want to spend on that, but it is what it is sometimes. So let's go back to our renderer types, because the next thing that I want to do in our renderer types is actually change up a couple more things in terms of our renderer interface. Specifically, we actually need to add a few more entry points, because right now all we can do is create or destroy texture, but we can't really determine what type of texture we're going to create or destroy. So we actually need 3 more functions, and I'm just going to paste these in because they're already complete with comments. So the 3 that we're going to add is texture create writable. So this is what we're going to call, instead of texture create, to create a writable texture. And that's because it's going to set some additional flags internally and set things up a little bit differently for a writable texture versus a non-writable texture. So we're going to have a different entry point for that. And then we're also going to have something here for a texture resize, which we're eventually going to use for like resolution changes and things like that. And then we are going to have a texture write data. And this is actually where we're going to be able to write pixel data to a texture. And right now, all it takes is an offset, a size, and the pixels to be written. So this is basically going to be able to write a chunk of texture data at a time, or write to the entire texture if that's what we want to do. So if we have some explicit texture data that we want to write to a texture, this is how we would perform that operation. Okay. So now that we have that, that is actually all the changes that we're going to need to make in our renderer types. So as far as that is concerned, we are actually done with that. The next thing that we should probably do is, let's see, we've already done our changes for the backend, at least for now. I'm thinking we should probably change the... There are a couple changes I want to make to the texture type itself. So I'm thinking we probably ought to go ahead and hit those up first. So if we go to resource types.h, and we have our texture here. Last time we actually added a is_writable to this to indicate if the texture can be written to or rendered to, what have you. And we have a has transparency, and that's also stored as a Boolean. And we're actually going to be adding some additional flags to this texture type. And the issue with this is a Boolean really only needs to be represented by a single bit of data. However, with multiple Booleans like this, we are actually taking up 8 bits per Boolean, which is a huge waste of memory when you're talking thousands of textures. So we're actually going to change away from using this Boolean type to, we're going to actually use texture flags instead. So we're basically going to combine these into a single U8 that is going to have various bits that can be flipped to turn these features on and off for a texture. So to represent this, we're going to have an enumeration that we're going to call texture flag. And one of the flags is transparency. One of them is if it's writable. And then another one is if it is a wrapped texture that was created via a wrapping mechanism that we're going to be adding instead of traditional creation. So an example of this is the swap chain images. Those are created for us, so we don't actually have any way to control or own those. Those are owned by the swap chain. But we are eventually going to be wrapping them in a texture structure. And so this flag would be set whenever that's true. Now, we're not getting to that yet, but just so that you guys are aware of what that actually is. So for right now, we have this has transparency and is writable, and you'll note that these are powers of 2. So this means that we can combine them and potentially have them overlapping. So you could technically have a texture that is transparent, writable, and wrapped all at the same time, or you could have any combination thereof. The other thing that we've done is, for convenience sake, we have type-deft a U8 to texture flag bits, just to make it a little bit more obvious as to what should be assigned to that field. And so what we're actually going to do is, instead of having the writable and transparency, is we're going to have a single field that replaces both of those. So I'm just going to slam that in here. And that's just going to hold the various flags for this texture. Now, if none of those things are true, obviously that's going to be a value of 0. This is a lot more efficient in terms of memory taken for our textures. So I'm going to go ahead and apply that, and then see what that breaks, because that's definitely going to break some stuff. So most notably, our texture system has broken because we now have the has transparency and has or is writable set to false when we're creating these default textures. So now actually we can just say dot flags equals 0 and eliminate this second line. So in fact, I'm just going to go through and whoops. Yeah, it should just be flags. I'm not sure why that's bleating at me. I guess the IntelliSense is not awake today. So what I'm going to do is I'm just going to copy this portion of the line and just overwrite these sections using our new flags, because our default textures have no transparency and they are not writable. So we can just set all those to 0 and be good to go. The other thing is down here where we're loading a texture, we are going to set the flags here. So we're actually going to start off setting the flags to, so if we have transparency on this, we are going to say text flags has transparency. And if we do not have that set, we're going to start that off at 0. And then, of course, since it's not writable, we're not going to set the flag for that. So all we actually have to do is set this flag here based on whether or not the texture has transparency. So let's go ahead and build that. And we've built successfully. So that is, I believe, all we need to do for that. Okay. So there are quite a bit more changes we're going to have to make to our texture system, but we're going to come back to those at a later time, I think. All right. Let's see. How do we want to proceed with this? So I think the next thing that makes sense, just looking at my notes here of all the things that we're going to have to change, we do need to do some work in the swap chain. We also need to set up a lot of stuff in our Vulkan renderer. And I think that's probably actually what we should do first, is the Vulkan renderer, because it doesn't really make sense to extend it to the front end just yet until we actually get the Vulkan renderer work done. So let me actually start with the Vulkan backend, because I think that's going to make the most sense. So Vulkan backend.h. And we've already done our rename here of this, but we need to implement our new methods for our create writable, our create, or our texture resize, and our write data. So I actually have, again, these things stubbed out with comments. So I'm just going to slam the function definitions in here via copy pasta. So we have our create writable, our texture resize, and our texture write data. And those line up, of course, with the interface that I already presented in the renderer types. So that is all we need to do for the H file. The C file for this is actually going to require, as you might imagine, quite a lot more work. So we already have our texture system in here, so we should be good as far as that is concerned. The swap chain now is going to actually need some changes as well. So let's see. Let's go to the destroy first, because that's swap chain. You know what? Let's actually not do the swap chain. We'll actually come back to the swap chain because there's going to be... Do I want to do that first? Yeah, I guess we can knock that out. But before we actually do that, we have to go to Vulkan types and make a change. So we'll go to Vulkan types INL. And in here somewhere, we should have the images and views for the swap chain. That's going to be in here. So right here, in the Vulkan swap chain, we have an array of images, an array of views. And our Vulkan image struct actually holds those things already. So it really doesn't make sense for us to sort of have to maintain this any longer. It really would make more sense if we go ahead and swap this to a structure that actually makes a little bit more sense. So we're actually going to get rid of images and views and just replace that with something that we're going to call render textures. And this is going to be an array of texture pointers. So this is going to be render targets, essentially. We're actually going to have a render target structure coming up here soon, but we're not quite in the position to set that up just yet. So what we're going to have here is some texture structures that are going to hold all the data that we need it to hold. One other change that we want to make, and I know I said I was sort of on the fence about this in the last video, but since this Vulkan texture data is only holding the image, I can't actually think of anything else that we're going to have to put in here. So I'm actually going to delete this structure, and then anything that is using that structure, we're just going to use a Vulkan image instead. So probably the first change that we're going to want to make right away is in Vulkan swap chain. So we'll go to the C file for that, and now we see here that we've got, of course, a bunch of errors. We are going to have to include our system texture system, because we are going to now be using the texture system to wrap the swap chain images. And so in our swap chain destroy, right after we call destroy is where we are actually going to destroy the swap chain images instead. So we're actually going to do a loop through the swap chain image count, and we are going to free the pointers to our renderer textures at sub I internal data. And remember, our internal data now is represented by a Vulkan image. We no longer have that structure that just had the Vulkan image in it. So obviously, because we're freeing this here, that means whenever we're creating a swap chain, we are going to be allocating some memory for that, and we are going to go ahead and add that to the array. So in our create method, next one. Okay. Code navigation failed there. VS Code's on a roll today, it seems like. Anyway, in our create, a little bit further down, we've got all this happening here about swap chain creation. None of that's going to actually wind up changing. There is a check down here, though, to see if we have swap chain images. So this is where we actually get the swap chain images. And so what we're going to need to do is, instead of checking for swap chain images, we want swap chain render textures. And if that's not created, then we are going to go ahead and create the array for that. So instead of render textures being in instead of having images, that's an array of VK images, we are going to have an array of texture pointers. So we're just going to swap that out. Everything else there should stay the same, so we have the same count, etc. As far as the views go, the views are actually going to be created as part of the texture. So we actually don't need to check the views anymore, because those are going to be handled as part of the texture. With that said, we are going to have to make some changes down here. So we're going to have two cases. The first case is basically where none of these textures exist, and the second case is where the textures are existing, but they just need to be, their internals basically need to be changed up because of a window resize or what have you. And so what we are going to do here is we are going to allocate our array, and then we're going to loop through our swap chain image count. And for each one, we are basically going to go ahead and k-allocate the internal data. And we have to do it this way because our internal data is a void pointer. So we can't just assign it to something randomly, right? We really should be just allocating this memory. And I realize that that's, obviously you want to try to avoid doing that, but there are certain circumstances where you need to do that, and this is one of them. So the next thing that we're going to do is we are going to come up with a texture name, because all textures have names. And so we are going to use this sort of default string here, which is called just __ internal Vulkan swap chain image. And then we have a 0 that's here, and we're just going to swap out the 0 here with the character version of the I, which will tell us the image index. So it'll be 0, 1, and 2, basically. And that will allow us to go ahead and have a uniquely named texture there. The next thing that we're going to do is we are going to wrap the internal texture, right? So we've already got our swap chain images At this point, we just need to go ahead and wrap that. So this is where we call our texture system wrap internal, which we don't have yet. We're going to be creating that. And basically what the wrap internal is going to do is it is going to take in all of these parameters and use the internal data, our Vulkan image here, as the internal data instead of creating it as it would do in a normal texture. So it's basically taking that already created internal data and wrapping a texture structure around it. So that is what that does. And again, we will fill that out here shortly. And then we're going to go ahead and just verify that the texture actually created successfully. Because if this fails, then we will wind up getting basically returned null. And we'll say, okay, well, we failed to generate our new swap chain image texture, and that's a fatal error, so we don't want to continue. So if we don't have our swap chain images created for the first time yet, we need to go ahead and wrap them. If we do already have them created, then this actually gets much simpler, because then all we have to do is call our resize method on that, on each one of those textures. So all we do is we just loop through our array here, and then call our texture system resize, which again, we have not yet done. We will fill that out here shortly. But it's basically saying take this texture, here is the new size of that texture, and then we're not going to preserve the data. Okay. So this, actually, I just realized we actually did something slightly out of order here. So I think actually, no. Okay, so this gets us the swap chain image count. Then we go ahead and generate our textures. Then down here is where we're actually going to get the swap chain images. And so what we're going to do here is we're actually just going to create a VK image array. And we're going to say swap chain images, and we're going to have that be a size of 32. This is created on the stack, so it doesn't really matter in this case if we're wasting a little bit of memory, because as soon as we're done with this operation, it's going to wind up changing anyway. So basically what we're going to have here is we're going to wind up with, let me see, we are going to change this last argument here to swap chain images, right? So it just fills out this array with the swap chain images. And then it comes through and loops through and it actually assigns those things. So let's do that. Yeah, I think it makes sense to do it right here. So for each image, we go ahead and we grab the internal data for our render texture at sub I. We update the handle, the width, and the height, so that is all updated as it should be. So our swap chain images here, this is where all of that is assigned. So just to recap what all of this does is on the first time we actually run this when we create the swap chain, we're going through and initializing the memory, initializing the array, allocating our internal data, wrapping that internal data, which does not actually have a valid image or view yet. And then we go ahead and just confirm that that exists. If we're going through this again, we are just going to call resize, which essentially just updates the texture's width and height and so forth. But it doesn't actually change the texture data, because anytime you resize the texture, you're going to have to re-upload data to it. And then here with the swap chain images, we are basically going to just update the image data that is in those internal Vulkan images with the swap chain images that we received here. So it's just a little bit more of a flexible way to handle this and allow us to actually use our texture structure that we had in place. Okay, so next comes views. And right now we're actually just going through and grabbing our, or creating our views rather, this way. And that's all well and good, except Now we don't have this swap chain images. We don't have the swap chain views here. We don't have this anymore. So this isn't actually relevant. So the first thing we're going to have to do is get a pointer to the current image, which is just the internal data of swap chain render textures sub I. And the image itself is not going to be swap chain images anymore. It's going to be image handle. And the only other thing that we're going to have to do is instead of creating to swap chain views sub I, we are going to be creating to the address of image view. So that way when we create our image view, it actually goes into this image as it's supposed to. Everything else there stays the same. Okay, our depth resources is also going to require a little bit of an update as well. So actually the depth resources itself is fine. It's actually the destroy that's actually wrong. So right here, we are actually destroying our image view. And let's see. Actually, I take that back. The depth resources is actually correct. It's the swap chain images that we have to update. So I was reading one thing and trying to say another and mixed it up. So basically, we have our image views being destroyed right here, which is not something that is pointing to the right place anymore. So we're obviously going to have to get our pointer to the image, just like we did when we're assigning it above. And then here we can just say image view. And that should destroy the image view properly. So that should be everything that we have to do in the swap chain. So basically what we've done here is we have just gone ahead and wrapped our swap chain images in our texture structure. So that will just kind of make things consistent for us when we go to access them, if we ever need to access them on the front end, which we will once we have render targets. Okay. So I think probably the next order of business is probably going to be, I'm thinking the backend is probably going to need the next largest amount of work. So I know that we have already actually done quite a lot of this, but the first thing we're going to have to do is go into regenerate frame buffers. Actually, we need the definition of that because, of course, we have we're getting our setting up our attachments here, and of course that's looking for swap chain views, which we no longer have. So the first thing that we're going to have to do is actually go ahead and get our image pointer like we've done before. So that's just going to be the context swap chain render textures sub I internal data, and that's going to be cold casted to a Vulkan image. And at that point, we can then say image view. And then we have our view for that. And then down here, we have the swap chain frame buffers for the UI pass, which is actually going to wind up taking the exact same thing because we're actually not using a separate image for this. If we were using a separate image, we obviously want to point to that image instead. But for now, it's just going to be image view. Okay, so that does it for the regenerate frame buffers. Next, we need to take a look at our texture create. So let's go ahead and text create. And we just need to modify some things in terms of texture creation. So our internal data for our texture is going to now be just a Vulkan image. So we're going to go ahead and k-allocate that. And then from there, we will go ahead and actually get a pointer to the image and probably, I'm thinking the image size should probably just be called size from now on. Let's see. What did I... Oh, right. This was another thing that I was fixing. So we have our structure name texture here, and our variables also name texture, which is kind of weird. So I'm actually going to rename this to just T, and then get rid of everything that looks at texture. So I'm just going to change these to T. Oops. And I'm not using the rename here because that is actually probably going to screw up quicker than it is going to actually help us. So I'm going to rename image size to size because it's not necessarily the image size. It's the actual size in memory. So it makes a little bit more sense to call that size versus image size. And then we actually, as far as our texture creation, we actually really don't need this load data here anymore because we're actually going to have a command to write data, which is going to contain a lot of that. So that's actually going to go bye-bye as well. And we're just going to jump to our image creation, which is going to end up changing. So we're going to have to definitely come back to that. But for right now, instead of passing the address of image, or data image rather, we are just going to pass image itself because it's already a pointer. So we have our pointer updated here. So that should be good. We also don't need this stuff here, as well as the transition layouts. We don't need that because that is going to be part of our new copy process. In fact, we don't actually need any of this stuff because all this stuff we're actually going to put in to a new method to handle that for us. So all we actually really need to do is call our write texture. So we have our Vulkan render write data function that we've created here. We still haven't filled it out, but that's basically going to take the place of everything that was going on there. So this allows us to sort of simplify this texture creation process by, sort of putting all that into one place. We also have texture that should just be T generation plus plus. And I think that is everything we need to do right there. So that looks pretty good. Our destruction is going to have to change a little bit as well. So I'm thinking probably the best way to handle this is just to, we have Vulkan texture data. This is just going to be Vulkan texture, or Vulkan image rather, not Vulkan texture. And we can actually just call this image. And then we can say if we have an image, then we need to destroy the image. We're going to zero the memory of that out. And we are actually going to change this to a Vulkan image. We'll go ahead and free it here. And then we'll zero out the memory of texture as well, and that should handle our destroy. So that looks pretty good. All right. So the next thing that we need to do is we really need to set up our new functions. So our create writable, our resize, and our write data. So before we can do that, we need a quick little method here just to a little helper method to convert from channel count to a VK format, because we don't want to be doing this in several areas of the code. So we actually just want to say if we have one channel, then we're just going to use the VK format R8 unorm. If we have two channels, it'll be R8 G8. 3 channels will be R8 G8 B8, and so forth and so on. You get the idea. And so what this is going to do is it's going to take the channel count and then say, okay, well, if we have something that's not supported in this list, what do we want to fall back to? And that'll be our default format. And that gets returned if this criteria is not met. So it's just a little bit of something for us to be able to reuse in the case that we need to perform that operation in multiple places in code, which we will. So next we're going to start by filling out our create writable texture because this is a little bit different than our texture so far. So the first thing that we're going to do is we're going to create our internal data. And that's just going to allocate just like we've seen before. We're going to get a pointer to the image. The image format is going to use our new format here. So we're going to take the texture's channel count, and then if for some reason that fails, we're just going to treat it as a 32-bit texture. And then we are going to go ahead and call our Vulkan image create. So that is going to have, a bunch of parameters passed to it. So the first thing it's going to need is, I believe, context. So we need to pass the address of context, and then it needs the type, which is VK image type 2D, and then it needs the width. So that's just going to be T width, and then height T height. The format is going to be the image format we just selected up here, and then the image tiling is going to be VK image tiling optimal. The usage for this is actually going to be kind of complicated because it has a bunch of usages. So it's going to be VK image usage transfer. It's going to be a source bit, but also a destination bit. So we're going to OR these together. So DST, because there's going to be plenty of scenarios where we're going to want to copy from one texture to another, so we need to be able to support both operations here. We also need VK image usage sampled bit, because this is going to be used potentially as a sampled texture. And then probably the last one that we're going to need is we are also going to use it as a color attachment, potentially. So VK image usage color, VK image usage color attachment bit. There we go. Okay, so that is the image usage, right? So there's going to be a lot of different potential uses for writable textures. So the memory is going to be the VK memory property. We want device local bit, so we want to use local device memory for this. The create view, we want to create a view for that. The image aspect flags is just going to be VK image aspect color bit. And then the out image is just going to be image. And that will give us everything that we need for the creation of our writable texture. And as I've mentioned before, really the biggest difference between that and a regular texture is just mostly these flags in here in terms of memory access and things like that. We're also going to set the generation. We're going to increment the generation of that texture. Okay, so we'll go ahead and format that, and that is good to go. The next one we need to set up is our renderer texture resize. So this is what's going to happen whenever we have a swap chain image resize, for example. Technically it means a new image, but in this case we actually are not going to be creating a new image for that, but we are going to be updating some properties within the image. So the first thing that we're going to look at is to make sure that we have a texture and that the texture has internal data. And basically, as I'm going to put here in the comments, resizing is really just destroying the old image and creating a new one. So the data is not preserved because there's no reliable way to map the old data to the new, since the amount of data differs. So we're not going to know how to sort of scale the pixels in that data from one image to another. And so we're going to go ahead and just destroy the internal image. And then we're going to go ahead and detect the format again using our new method here. And then I'm actually just going to paste in the image creation here because it's mostly the same as what we've already seen before. So the difference here is it basically takes our new width, our new height, our image format, and then basically everything else is just about the same. So that is the texture resize. So that's pretty straightforward stuff once you break it down. And finally, we have another new method here for our writing data. And this is where we're going to put all the all of that that logic that we removed basically for the command buffers and all that stuff to upload texture data. We're going to do that here instead. So the first thing we're going to do is obviously get a pointer to the image, the internal Vulkan image. We'll go ahead and grab the image size too. It's just a quick calculation of width, height, and channel count. And then the image format, again, we're going to go ahead and grab that. And then the first thing we're going to do after that is create a staging buffer. So this is very similar to what we had here before. It's just instead of during the texture creation, we're doing it here so that we could reuse this code for other scenarios. So we have our staging buffer here. And the next thing we're going to do is we are going to go ahead and load data into it. So that is thankfully just, it's actually pretty simple. It's a single line call. So we're going to go ahead and load our data into that. And then we're going to go ahead and set up a command buffer right here. And we're going to allocate and begin a single use command buffer. And we're going to use that command buffer to go ahead and transition the image layout. And at that point, we will copy from the staging buffer to the actual image itself, the actual image memory. And from there, we will go ahead and transition the layout once again. So from here, we're basically transitioning it from any sort of layout to our transfer destination optimal. We copy the data to it and then transfer from, or transition rather, from transfer destination optimal down to shader read only optimal. Now this, if it's a writable texture, we probably are going to need to do something different here. But for right now, until we actually get to that point and hit an issue with it, I'm going to leave this as is. And then of course we need to end our single use buffer and go ahead and destroy the staging buffer. And naturally at the end, we're going to increase the generation. So really nothing new. We've seen all this logic before. It's just a matter of really moving it and making it a little bit more flexible. Okay, so I believe the destruction has already been updated. Yeah, I think that looks good. Our creation looks good. I think that is actually all we need to do. Let's see. Actually, no, there is one more thing down here. So acquiring our resources and actually applying our texture data is going to change a little bit because it is still looking at that Vulkan texture data structure. So that is one thing that we're going to have to change a little bit. So that is going to be, instead of Vulkan texture data, that's going to be a Vulkan image. And in this case, we're just going to rename this to image as well. And then this is going to be just a cold cast of the internal data to that. And then we should just be able to say image view. Okay. And I think that is actually the only things we need to modify for that. All right. So the last thing, let me take a look because I could have swore there was something in acquire resources that we also had to change. I think it was here. Yes, there is a small optimization that we can actually do here. So right here, we are technically, this is an update that was made in the last video, but right here we are actually copying the texture maps over, and we could just do them all at once with a mem copy operation. So that would consist of right here, we can just say, okay, we'll take all of the maps, copy them to our texture maps, obviously for the number of textures we have. And then we can eliminate this operation right here. And this should be technically change to set unassigned texture pointers to default until assigned, because if we already have something that's assigned here, we're not reassigning it. We're only doing it if it's unassigned. So just a minor tweak in the code there. It wasn't really breaking anything, but this is a little bit cleaner. Okay, so that is everything I think we need to do in the back end. So I think it's time we probably should move on to the front end and implement our changes there. So let's start in the H file. And right under create texture, which I think is going to be around here. So our texture create, texture destroy. I'm actually going to put right here after destroy. I'm going to input our 3 texture functions, which again, I'm just going to copy pasta this because it has all the comments that we need and I don't feel like retyping that. So we have our create writable, our resize, and our write data. And these are the front end access point for that. So it really just passes through to the back end. So if we go here, let's go to our render texture destroy, and we're going to put it right below that. So in our front end, we are going to put in our create writable, which again, I'm just pasting this because it's just a pass through, so there's not really much to see there. So we have our create writable, same thing for our texture resize, it's just a pass through. And then of course the same thing goes for our write data, it's just a pass through. So there's not really a whole lot of exciting stuff there. So I'm just going to copy paste that and move on. Now one thing that we do need to do is go to our renderer backend C, because we actually have our create and destroy here for our textures, but we have not added the function pointers for our create writable and our write data. So we actually need to go ahead and slam those in there as well. And actually, do we not have our texture resize in here? We do not. So we actually need to set that up as well. So texture resize equals Vulkan render texture resize. So that way we have proper function pointers for everything here. Render a backend. Oh, right. Does that not have... Actually, I don't think we need that. Okay, technically we do need it. Right now we're getting away with it because it's only called from the back end, from the swap chain, but we actually do need... We do need this on the front end as well. So we actually need to go back to our render types INL. Let's see, we have... Oh, we do have it here. Create writable, texture resize, texture write data. Did I just name it the wrong thing? Oh, yeah, the renderer bit's not supposed to be there. That's what it is. There we go. Okay. Right. So the renderer front end should be all set as well. Okay, so now all of our function pointers are set up. So we have our changes to the front end and the back end set up. So really, I think the last piece of this is actually going to be just the updates to the texture system, which is going to be quite a lot, actually. This might actually be the largest update that we actually have to put in place. So, so how do I want to tackle this? Probably let's go to texture system. And we're actually going to have to change some things here. So we have a texture system acquire, but we also need a way to acquire a writable texture, because what this acquire does right now is it assumes that we're going to be loading a texture from a file, And so it connects all those pieces. It handles loading the texture from a file and uploading that data to the GPU and all of that. But for a writable texture, that doesn't make sense. So we actually need a different entry point for the acquire for a writable texture. So we're going to put another entry point in here that we're going to call texture system acquire writable. And this will allow us to actually provide a few more parameters that we normally wouldn't have to provide when we're loading a texture. So we're going to say here, what's the name of the texture, the width, the height, the channel count, and whether or not it has transparency. And then let's see. So, right, that should be fine. Okay, so our texture acquire writable is something we're going to have to fill out. And then we are going to be using our new methods for acquiring wrapping an internal texture. So let's go ahead and put these. We have release here. Let's put these before our default getters. So, whoops, I think I missed. Yeah, there we go. So what we're going to have here is a collection of new functions. So we're going to have a texture system wrap internal. This is what was called from the swap chain when we already have our internal texture data and we just want to wrap that in a texture structure. This is what we use for that. So it takes a name, obviously, width, height, channel count, whether or not it has transparency, whether or not it's writable, if it should be registered as a texture that is sort of can then be acquired from the texture system, because we might not always want that. And then a void pointer to the internal data. So this is what the swap chain calls when it needs to wrap those Vulkan images in a texture. We also have this texture system set internal. So when we need to update the internal data on a texture, we pass a pointer to the texture and the internal data that needs to be set on that, and it just updates the pointers internally. We have our texture system resize, which takes the texture and what the new width and height should be, and then whether or not we should regenerate the internal data or not, because we're not always necessarily going to want to do that. So an example of that, again, is the swap chain images. We're not going to automatically want to regenerate that internal data because those internal data or those images are generated by the swap chain. So we're not going to want to do that. So we want to be able to control that. And then we also have our texture system write data, which allows us to write data to a texture. Okay. So I believe that is actually all the changes that we need to make on the H file of the texture system. So now comes sort of the large change to the texture system. And I knew that this was coming, but I've been putting it off for a while because it's kind of a big one. So one thing that I want to sort of point out is we have this load texture, which does all of this logic here for looking at transparency and then creating the texture, and then actually this is actually not the one I was thinking of. We have, where is it? Our acquire is the one I'm thinking of. Acquire. So our acquire texture is basically doing a lookup of the texture reference, creating it if we need a new one, incrementing its reference count if we don't need a new one, and then assigning to the hash table and all of that. So it's handling all of that. But then we're also doing a lot of this similar logic within the release. So we're looking up, we're decrementing the reference count in this case, and then updating the hash table. So this is another case where we're sort of repeating ourselves, and that's kind of dumb. So what I'm going to do is refactor acquire and release, because we're going to have another acquire and we don't want to copy this logic again. I'm going to refactor this into something that sort of all goes through the same process in terms of actually dealing with texture references. And so what I'm actually going to do in this case is it's going to be a new function that I'm going to create at the bottom here. And I'm going to slam the whole thing in at once. because it's kind of a large function, and we're gonna sort of just step through it. So we're gonna have this new thing called process texture reference, and what it does is it takes the name of a texture, the reference diff, which is an I8, so we can subtract or add. So basically we pass either a 1 or a -1 here. So if we're acquiring, it would be a 1. If we're releasing, it would be a -1. And that just allows us to not have to branch on that logic. And then whether or not it should auto-release, whether or not we should skip the load, and that's skip load of a file. So for our writable textures, we would want to skip the load. For our regular textures, we would not want to. And then it's going to return an output texture ID. So most of the logic in here works exactly the same way as what we had before. It's just kind of combined all into one place now. So that way everything here goes through sort of one code funnel, if you will. So the first thing we do is obviously check for a state pointer. And then we have a texture reference here. And we go ahead and do a lookup. So if the reference count starts off at 0, then one of two things might be true. So if we're incrementing references, then that means that the entry is new. So if we're starting at 0 and we're incrementing, we know we're creating a new one. If we're decrementing, then that means that the texture doesn't exist, because we have something that has returned 0 textures. That means that nothing's referencing it, so therefore we have nothing really to release. So if the texture doesn't exist, I should say it doesn't exist if not auto-releasing, right? So within this case, we go ahead and check to see, okay, if our reference count is 0 and our diff is positive, then that means that this can only be changed, or that means that we're loading a new texture, and we can go ahead and set auto-release. And remember, we only change auto-release the first time a texture is actually created. Otherwise, that means that this is negative, and we go ahead and check to see if it's auto-release. And then if it's auto-release, we just put a warning there that says we tried to release a non-existent texture, and spit out the texture name and return false, because this, in this case, would have failed, but it's not necessarily something that's critical. It's just like, hey, why are you trying to release something that doesn't exist? And then otherwise, if it's not auto-release, then it'll say we tried to release a texture where auto-release equals false, but references was already 0. So it still counts as a success, but we want to warn about it. Here, if our reference diff is not 0, in other words, we are incrementing or decrementing, we go ahead and add the reference count here. So technically, I guess we don't even really need this check at all. We can actually get rid of that because it's going to be the same no matter what. If it's 0, it's not going to do anything. If it's -1, it's going to subtract 1. If it's 1, it's going to add 1. Then what we do is we go ahead and we take a copy of the name, because once we wipe out the texture, that name is going to be wiped out with it. So we take a copy of the name, and then we say if we're decrementing, then that means that this is a release. So we check to see if the count has now reached 0. And if it has, then that means that if the texture is set to auto-release, that we should go ahead and destroy it. So we destroy it, invalidate the handle, so forth and so on. We do spit out a message here that is a trace message. We probably are going to want to shut that off at some point, but for now we go ahead and say, hey, we've gone ahead and released this. If the texture count or the reference count has not reached 0, then we spit out what the reference count is, just as a trace message so we can kind of debug it and see things happening. Okay, so if our reference diff is not less than 0, then it's greater than 0. So that means more than likely we're incrementing. We probably should be specific about this, but then again, since it's a private method, I'm not really too worried about that. So if the handle that we have gotten is an invalid ID, then that means that there was no texture existing. So that means that we need to find a free index, and we've seen this find an index logic before, so I'm not going to go into that. If for some reason we were not able to find an empty index, then we go ahead and bleat about it. That's a fatal error, and we return false. That's definitely a big deal, and we need to bleat about that so that the configuration can be changed. Next, we go ahead and get a pointer to a texture. So that's in the registered textures array. We just grab the address of that at ref handle. If we skip the load, we just go ahead and say, hey, we skip the load for this particular texture, but it's expected. Otherwise, we go ahead and we load the texture, make sure that that load was successful. If not, bleat about it, return false, etc. Go ahead and set the ID. Say, okay, texture does not exist yet, but we've created it. Now the ref count is this. So if we get all the way down here, in other words, we already have a ref handle that was not invalid ID, then all we're actually going to do is say the out texture ID is ref handle, and we would have already incremented the reference count here, so there's actually nothing left to be done, at least at this point. So no matter which we wind up doing, whether we're incrementing, decrementing, or any of that, we go ahead and set the hash table. So this always gets set, so we update that value with the reference count, and then we go ahead and return true. If for some reason we get to this point, which if you look here, would mean that our hash table did not return something, then we're going to say we just failed to acquire a new ID for name blah blah blah, invalid ID returned. And then if for some reason our state pointer is null, we go ahead and we just say, hey, we tried to process a texture reference before the texture system was initialized, return false. So this looks like a lot of code. It looks kind of complicated, but it really isn't. It's just, there's a lot of steps that we needed to step through, and it maybe added a tiny bit of complexity to roll all those functions into one. But in the end, it's actually going to save us from a lot of repeated logic. Okay. So we have that. We have already updated our flags. So we already did that work in here. So that is good to go. So the next thing that I think is kind of going to be useful is we have these get default diffuse texture things here, and this is all very repetitive, right? And we're just kind of occupying a lot of lines here for just simple stupid stuff. And so what I would actually like to do is I think we should probably go ahead and macro this. And so what I'm going to do is right above our get default texture, I'm going to create a macro that says return texture or texture pointer or null. And this is basically going to take in a texture, and it's going to take in a function name. And basically it's going to mirror this logic down here. So it's going to say if the state pointer exists, then we're going to return the value of texture that's passed here. So that's the exact same thing that we're looking at here, right? So this one returns default texture, this one returns diffuse texture, and so forth. Otherwise, we're going to spit out an error. And we see that all of these things called before texture system initialization, null pointer return. We've repeated that as well. So we put that called before here, and we just insert the function name. And so what these all are going to wind up looking like is instead of all of this, we now have that. And it's much, much cleaner. So I'm just going to update this all the way down and get rid of all of this, because we're just going to let the macros sort of build that code out for us. And it's going to wind up being exactly the same thing. It just makes our code a little bit easier to read. So we have that. And then I need this again for here. And normal texture. And we can get rid of that. So save ourselves a little bit of repeated code there. Okay. So the next thing that we need to do is we have our, let me actually put this next to the H file. So we have our new functions that we've added here. So we have our resize, our write data, our set internal, and our wrap internal. So we need to actually fill those things out. And so what the resize is going to look like is actually going to be pretty straightforward. In fact, I'm going to put this right above, let's see, right here. So our texture system resize is going to do pretty much what you're thinking it's already going to do. So we are going to first check to make sure that it's writable, because we shouldn't be calling this method on a texture that's not writable, because it doesn't make sense to try and to resize a non-writable texture. At least I don't think it makes sense, at least for right now. So we're going to look at the flags and say, is the is writable flag set? If not, we're going to warn about it and return false. Otherwise, we're going to set the texture's width and height. And then we're only going to allow this for textures that are not wrapped. So if the texture is wrapped, we probably should not, I should say it's not wrapped and the internal regenerate internal data is not set. So nope, I think I still said that backwards. So we're only going to, we're going to check to see if the texture is wrapped. If it is not wrapped and the regenerate internal data is enabled, then we will go ahead and call the renderer texture resize. And this is because if we've wrapped the texture, that means that the internal data is already probably owned by the renderer, and it's already handled that resize operation. So we actually don't want to call that again. So we want to make sure that we're not calling the renderer resize on a wrapped texture. So we go ahead and do that conditionally, if and only if we need it, and then increment the texture generation and return true. If for some reason we don't pass something for our texture pointer here, we just return false. Okay. All right. So our texture system set internal, which I'm going to put above this, is super simple. All it really does is check to make sure that we have a texture pointer, and then sets the internal data to the internal data that's passed in, and we increment the generation, and then we just return true. Otherwise, we return false. So that's really, really simple stuff. Nothing complicated there at all. So the next thing that we want to do is we actually need to set up our wrap function, because we've talked a lot about texture wrapping, but we actually have not seen what that actually does. So again, I'm probably just going to copy paste this, because it's probably going to be a lot quicker than me sort of coding this completely from scratch. But we're going to start off with an invalid ID. We are going to start off with a null texture pointer. And then we're first going to check to see if we're supposed to be registering the texture, because that is going to make a difference in what we call here. So if for some reason we're saying that we want to register the texture, yet we are saying that we want to wrap the texture, wrap texture should never be auto-released, because it means that the resources are created and managed somewhere within the renderer internal. So the primary example of this, of course, is the swap chain textures. So what we're doing here is we're processing the texture reference, but instead of passing through the auto-release as we would from elsewhere, we're saying we do not want to auto-release and we want to skip the load. And then the reference diff obviously is going to be 1. So this is one of those places where we're calling our process texture reference instead of having that duplicated code all over the place. So after that, we will go ahead and update the texture pointer to be at the registered textures at the ID that was returned. So if for some reason this returns false, we're going to go ahead and bleat about that and return 0, which will give us a null pointer here, which Anything that looks at that will know to say, hey, something happened here that gave us a null texture. That's bad. We should bleat about it and return. Okay, so that is if we are registering the texture. If we are not registering the texture, then we actually have a little bit less work to do. So one thing that we do need to do is we are going to have to allocate some memory if we're not registering the texture, because we're not going to have a texture pointer, right? Because we wouldn't have gotten this from our registered textures like we would if we're actually registering it. So what we are going to do is put out a trace message saying we are wrapping an internal texture called whatever, but we're not registering it, resulting in an allocation. So it is up to the caller of this to free this memory, right? So in other words, when we call this from the renderer, it is up to the renderer to go ahead and free this, not us, within this texture system. So it's basically, here's a pointer, now you deal with it. Okay, and so that sounds like it would be bad, but it actually makes sense when you stop and think about it. So either way here, at this point, we're going to have this texture pointer assigned to something. It's either going to be something that's freshly allocated or something that's grabbed off the registered textures array. So all we need to do now is just fill out the information. So we're going to fill out the ID, which would have been either invalid ID, which is going to remain to be the case if we're not registering it, or the ID that was returned by process texture reference. So we go ahead and set that. And then we take a copy of the name. We set the width, height, channel count. Generation is invalid ID for now. And then we go ahead and we set the flags depending on what was passed in here. So if we have transparency, we set that. Otherwise, that's 0. If it's writable, we set that. Otherwise, it's 0. And then we are going to definitely set the isWrapped flag here. So we're just setting those flags by or equalsing them, and then setting the internal data here. And finally, Finally, we return t, which is our texture pointer. And that gets us our wrapped texture. So I hope that makes sense thus far. Okay, so the next thing that we're going to have to do is adjust our texture system release. And by proxy, we're also going to have to adjust our acquire. So we're still going to do this check to see if the texture name is equal to default texture name. We should probably be checking against the other default textures as well. In fact, I'm going to put to do here. Check against other default texture names as well, question mark. Okay, so we probably should be doing that, but I'm not going to do that for right now. And what we're going to do is this whole section that is basically dealing with texture references and hash table sets and all this stuff, this entire thing is going bye-bye. Because all we really need to do is we need an ID, and then we just need to decrement the reference count, which is a call to our process texture reference. So as you can see, there's a lot less code here because it's all handled by what we pass to process texture reference. So in this case, we are passing along the name, and then since we're decrementing, we pass -1, and then we're passing auto release is false, skip load is false. Since we're releasing, doesn't really matter what gets passed there because we are unloading. So it's not really used, but that's fine. And then it outputs the ID. And then if that fails for some reason, it bleats about it and returns, but otherwise it just continues on. So I guess this return really isn't necessary because this isn't returning a true or false. Okay, so the next bit is the acquire bit. In fact, let's go ahead and fill out the acquire writable because that's actually the last thing that we have to add in here. So I think it makes sense to fill that out. So let's go ahead and put that right here. So we have our texture system acquire writable, And just like we have done in other places in code, we are going to start off with a invalid ID, call our process texture reference. In this case, we are going to use a 1 for our reference diff because we are going to be incrementing. We are not going to auto-release because this is a writable texture. We don't want to auto-release that. We're going to skip the load because obviously we're not going to be loading from a file. And then we're going to output to ID, which is here. So once we've done that, we can actually continue on writing all of the properties out to the texture that we get right here. So we are going to be registering a texture. So we go ahead and get the registered textures ID. We get the registered textures sub ID rather. We get the address of that to get our pointer. We set the ID, copy the name, width, height, channel count, generation, all things we've seen before. The internal data is set to 0, and then we do render texture create writable, and we pass T through to that. That will create our internal data for us. That's writable as we need it. And then we go here and we say we want to return. Actually, we could probably just, instead of returning the address of all that, we could just return T. Keep it simple. So that is our texture system acquire writable. Not a whole lot of complexity there. It looks and sounds more complex than it is. So the next thing, and I believe this is actually the final thing that we have to do, is our texture system acquire. So we are still going to go ahead and check this. In fact, we should probably also check against other default texture names, question mark. So we should probably check against other names as well, because we're only checking against default here. So I'll put a to do, we'll come back to that later. So we have next all this logic here for the hash table and reference updating and all that. As you probably have guessed, that's all going to go bye-bye. So what we're going to do instead, in fact, this can go bye-bye as well. So after we check that, we are just going to do the same thing that we did for our acquire writable, and we are just going to get a texture reference. So we're going to start off with an invalid ID. We're going to be incrementing, pass along auto release this time, that's passed here. We are not going to skip the load. We are going to output that to ID. If for some reason there is an error, we are going to return 0 instead of a pointer to a texture. And then if we are successful, we are just going to return the address of the registered textures sub ID, which is here. So that is all that is needed for our texture acquire. And I believe that is actually all the changes that we need to make for this video. So what I'm going to do now is I'm going to do a clean, whoops. I think I actually hit a different button there. So clean, build, see if we broke anything. Looks like we did. Let's see, pointer types. So our render textures. Oh, right, this should be a double pointer cast here. And this should be a pointer to a texture here, because that is the size of each individual element times image count. Okay, I think that's right. Looks like we have a couple more errors. So process texture reference. Oh, I think I know what this is. So, whoops. So this is declared and defined all the way at the bottom of the file. So we just need to actually come up here and put this, I guess we could just put it here so that that's declared at the top of the file. And it looks like we're good. So let's go ahead and run. Okay, and we'll move around. And it looks like we are good to go. We'll switch our textures here just to make sure that that's all working. We'll switch our modes here just to make sure that all of our data looks good, and it does. So this is sort of the precursor to the next big section that we're going to be updating, which is our view system. So there are a couple of other things that are coming down the pipe before we hardcore jump into views, but that is coming. So I hope this video made sense to you guys. I hope it's informative. Thank you guys so much for watching. I really appreciate you guys. If you liked the video, please toss it a thumbs up. Those really help me out quite a lot. And if you have any questions, comments, feel free to drop those in the description below and I'll answer them to the best of my ability. And if you haven't already, consider subscribing and go ahead and hit the little bell icon there to get notified as to when new videos in this or my other series drops. And I will see you guys next time.